Hello all aeronautic geeks. Today we're going to talk about automatic direction finder. And this I read it from thaitechniques.com. So you can go out and check there too. ADF automatic direction finder is the radio signals in the low to medium frequency band of 190 kHz to 1750 kHz. It is widely used today. It has the major advantage over VOR navigation in that reception is not limited to line of sight distance. The ADF signals follow the curvature of the Earth. The maximum distance is depend on the power of the beacon. The ADF can receive on both AM radio station and NDB, non-directional beacon. Commercial AM radio stations broadcast on 540 to 1620 kHz. Non-directional beacon operate in the frequency band of 190 to 535 kHz. ADF components. Number 1. ADF receiver. Pilot can tune the station desired and to select the mode of operation. The signal is received, amplified and converted to audible voice or Morse code transmission and powers the bearing indicator. Number 2. Control box. Digital readout type. Most modern aircraft has this type of control in cockpit. In this equipment, the frequency tuned is displayed as digital readout. ADF automatically determines bearing to selected station and it on the RMI. Number 3. Antenna. The aircraft consists of two antennas. The two antennas are called loop antenna and sense antenna. The ADF receives signals on both loop and sense antennas. The loop antenna in common use today is a small flat antenna without moving parts. Within the antenna are several coils spaced at various angles. The loop antenna sends the direction of the station by the strength of the signal on each coil but cannot determine whether the bearing is to or from the station. The sense antenna provides this latter information. Number 4. Bearing indicator. Displays the bearing to station relative to the nose of the aircraft. Relative bearing is the angle formed by the line drawn through the center line of the aircraft and a line drawn from the aircraft to the radio station. Magnetic bearing is the angle formed by a line drawn from aircraft to the radio station and a line drawn from aircraft to magnetic north, bearing to station. Magnetic bearing equals to magnetic heading plus relative bearing. Type of ADF indicator. 4 types of ADF indicators are in use today. In every case, the needle points to the navigation beacon. Those 4 types are: 1. Fixed compass card. It is fixed to the face of the instrument and cannot rotate. 0 degree is always straight up as the nose of the aircraft. The relationship of the aircraft to the station is referred to as bearing to the station, MB or aircraft to magnetic north. This type of indicator pilot must calculate for bearing by formulas. Magnetic bearing is equal to relative bearing plus magnetic heading. Number 2 is rotatable compass card. The dial face of the instrument can be rotated by a knob. By rotating the card such that the magnetic heading MH of the aircraft is adjusted to be under the pointer at the top of the card. The bearing to station MB can be read directly from the compass card without calculation and make it easy for pilot. Today, they design automatically rotate the compass card of the instrument to agree with the magnetic heading MH of the aircraft. Thus, MB to station can be read at any time without manually rotating the compass card on the ADF face. Single needle radiomagnetic indicator. Radiomagnetic indicator (RMI) is an instrument that combines radio and magnetic information to provide continuous heading, bearing, and radial information. The face of the single needle RMI is similar to that of the rotable card ADF. Dual needle radiomagnetic indicator. The dual needle radiomagnetic indicator is similar to single needle RMI except that it has a second needle. The first needle indicated just like single needle in the picture. The yellow needle is a signal which indicate the magnetic bearing to the NDB station. The second needle is the green needle in the picture. The second needle, green, is point to VOR station. The dual needle indicator is useful in locate of an aircraft. Operation. ADF operate in the low and medium frequency bands. By turning to NDB station or commercial AM radio stations, NDB frequency and identification information may be obtained from aeronautical charts and airport facility directory. The ADF has automatic direction seeking qualities which result in the bearing indicator is always pointing to the station to which it is tuned. The easiest and perhaps the most common method of using ADF is to home, to the station, since the ADF pointer always points to the station. The pilot can simply head the airplane so that the pointer is on the 0 degree or nose position. When using a fixed card ADF, the station will be directly ahead of the airplane, since there is almost always some wind at altitude and you will be allowing for drift, meaning that your heading will be different from your track. Off track. If the aircraft is left off track, the head of the needle will point right of the nose. If the aircraft is right of the track, the heading of the needle will point left of the nose. For a fixed compass card, if you are not flying, homing, and you want to fly heading at some degrees, you must use the formula MB plus MH plus RB to find out what degree the ADF pointer should be on. Today, the fixed card indicator is very unsatisfactory for everyday use, which can still be found on aircraft panels, but not many planes. The pilot actually uses it due to it has easier type of indicator. For rotable compass card, it was a big step over the fixed card indicator. The pilot can rotate the compass card with the heading knob to display the aircraft MH straight up. Then the ADF needle will directly indicate the magnetic bearing to the NDB station. For single needle radiomagnetic indicator, the compass card is directional gyro and it rotates automatically as the aircraft turns and provides continuous heading. It accurately indicates the magnetic heading and the magnetic bearing to the beacon. The instrument is a hands-off instrument. For dual needle radiomagnetic indicator, it gives the pilot information the same as the single needle, such as aircraft heading and the magnetic bearing to the NDB. The second indicator will point to VOR station. This helps pilot to check the location of the aircraft at that time.